Okay, so welcome back to another binomial expansion problem. This is a much more challenging question. It asks us to write the first three terms of 2x squared minus 3y to the power 16. Now, there's a little bit of, mercy, because we only have to do three terms rather than doing all 17 terms. Often there's another way of phrasing these questions as well too, and I'll put together a video showing that. But we just want to write out the first three terms. Well, the coefficients of the first three terms are actually quite easy. Because I have 16 elements, it's going to be 16 choose 0, 16 choose 1, and 16 choose 2. Now, I do want to be careful in saying that these are the coefficients because the coefficients have a contributor coming from this choose notation, but they also may have a contributor coming from the term. Because the first term here contains a number 2, that 2 is going to contribute to each of these coefficients. And because the second term contains a negative 3, that negative 3 is going to contribute to each of the coefficients as well. Now, in the binomial expansion, you take this value, whatever it is, and the exponent counts down from 16. So this is going to be 2x to the power 2 from 15. This is going to be 2x to the power 2, 14. All right. Now that second term, this negative 3y, that counts up. So it starts from 0, it goes negative 3y to the power 1, and then this will be negative 3y to the power 2. All right. Now fortunately, I've got my calculator with me, because it's going to be quite challenging to go ahead and do some of these examples without a calculator. You could do this by hand. I don't really have 2 to the power 16 memorized, but I suppose I could work it out had I needed it. I do have 16 choose 0 memorized though. That's 1. So now I'm going to raise this to the power 16. So this will be 2 to the power 16. Which is 65,536, and it'll be x to the power 32. Wow. Well, that's because when you raise a power to a power, you multiply the powers. Now, anything to the power 0 is 1, so that's just 1. And this first term is evaluated to that. Now let's do the second term. So 16 choose 1, well, that's another easy choose notation, that's 16. Now this will be 2 to the power 15. 2 to the power 15 is going to be 32,768. And this will be x to the power 30. But now I actually have a negative 3y here. And then I'll have 16 choose 2. Now, I'm going to bring up the TI-84 to show you how to get to your choose notation. You can press math, and then if you go over to probability, you can choose NCR for choose notation. And so we want to do 16 choose 2. And that's 120. So this will be plus 120. Now we still have 2 to the power 14, so we'll do 2 to the power 14. That's 16,384. Again, it'll be x to the power 28. And then we'll have negative 3 to the power 2, or 9y squared. The common mistake that I see is people forget to apply this squaring, or whatever the exponent is here, into the variable as well too. So just be careful and watch out for that. And so that's my last term there. Now, not really my last term because we know that this goes on because there's 16 terms of this. Okay, one last thing to do is to just multiply all of our values together. So I have constants. 1 times this times 1 is just simply 65,536. Now, I'm not going to do this without my calculator, so I'll do 16 times 32,768 times negative 3 to get negative 1,572,864, and that'll be x to the 30. Now notice that this is negative and our second term is negative. We'll talk about that right before the video ends. And then this one, I kind of jumped the gun here and I said that it's positive, but it's because it's 120 times 16,000 times 9, so it is going to be positive. So 120 times 16,384 times 9 is 17,694,720, x to the power 28ths, and y to the power 2's. So now this keeps on going. And technically, there's an error there. And I want to show you where that technical error is. Well, because we have a negative sign, and that negative sign belongs to the second term, everywhere where the exponent on the negative sign is even, that's going to contribute a positive multiplication into those terms. So the first term and the third term were positive because our degree starts at 0, counts up by 1 to get to 2. So those are places where the negative cancels out, leaving you with a positive term. In the middle, though, this negative did not cancel out. So because the negative did not cancel out, we were left with a negative term here. This sign is going to end up being a negative sign. And in fact, what we'll notice is that the signs will alternate. That'll happen regardless of whether this one is negative or this one is negative. If the first term is negative, your odd terms, so the first and third would be negative and every other one would be positive. If the second term is negative, your even numbered terms, so 2 and 4, are going to be negative. If they're both negative, well, then that's going to cause some interesting interactions. You could common factor out the negative if they're both negative. And there's many ways of dealing with that. So this is a question of how to write out the first 3 terms of a binomial expansion.